All right, let's get right into it. We're going to explore one of the most fascinating and frankly contradictory places on the entire planet, the Hanford site in Washington state. It's a place that really makes you ask a huge question about the massive, complex, and often dangerous things we create. How in the world do we clean up our own messes?
See, on one hand, because Hanford was totally closed off to the public for decades, it accidentally became this incredible wildlife refuge. It's home to a just stunning array of life, a vast, thriving ecosystem that is, by any standard, a huge conservation success story.
And then, on the other hand, it is one of the most contaminated places on Earth. The very mission that protected it from human development also poisoned it with tons of radioactive and hazardous waste. And that right there, that's the Hanford Paradox, a biological treasure sitting right on top of a toxic tomb.
You know, that feeling Hanford gives you, it actually has a name. It's not just beauty and it's not just fear. It's both, all at once. Psychologists call it threat-based awe. That feeling of being completely overwhelmed by something immense and powerful, something that is both magnificent and deeply, deeply dangerous. In a nutshell, that's Hanford.
So to really get our heads around this, we need to understand the sheer scale of the problem. And the numbers here, they're almost impossible to comprehend. They're what you might call sublime, in that classic sense of the word, just terrifyingly vast.
First up, the size, 586 square miles. To put that in perspective, that's about half the size of Rhode Island, an absolutely enormous territory, all dedicated to a single, top-secret purpose.
And what about the timeline for cleanup? Well, the official land use plan says it's going to take at least another 50 years just to get its goals implemented. And believe me, a lot of people think that's being optimistic.
And then, there's the cost. The latest government estimates project that total cleanup could end up costing more than $589 billion. It is, without a doubt, one of the largest and most expensive environmental cleanup projects in all of human history. This map, right from the government's own environmental report, shows us exactly where this story is unfolding. Back in 1943, the U.S. government took over this huge piece of land in southeastern Washington. It was a key part of the Manhattan Project, and they chose it because it was isolated, it had the Columbia River for cooling, and there was tons of hydroelectric power nearby.
To put it simply, this site was basically ground zero for the atomic age. The B reactor right here produced the plutonium for the very first nuclear explosion, the Trinity test, and for the bomb that was dropped on Nagasaki, which effectively ended World War II. But that world-changing mission came with a staggering cost, a toxic legacy of waste left in the ground, in the water, and in the air.
So how do you even begin to bring order to a place like this? Well, in 1999, the government tried to answer that very question by releasing this monumental document, basically an attempt to program a logical, rational future onto this incredibly chaotic landscape.
And this is that document, the Comprehensive Land Use Plan. We're talking thousands of pages long. It's an incredible artifact of human ambition, really. It's a massive white paper that tries to use bureaucracy and science and foresight to map out a 50-year course for one of our most complex and dangerous creations.
And right at the core of this whole plan is a fundamental clash of values, and it's laid out perfectly in its proposed alternatives. So what do? Do you go with Alternative 1 and treat Hanford mainly as a nature preserve, locking it down to protect its fragile ecosystem? Or do you go with Alternative 3 and push for economic development, returning land to farming and industry, trying to squeeze some new value out of this wounded landscape?
And just look at these maps. They're pulled directly from that planning document. They show you exactly what's at stake. On one side, you've got the priority habitats, the shrub steppe, the wetlands. On the other, the specific locations of priority species. We're talking bald eagle nests, salmon spawning areas. Every single decision in that plan is a decision about these specific, real-world places.
But it's not just a simple choice between ecology and economy. There's this deeper, human dimension that the plan has to grapple with. This land is sacred to several American Indian tribes who have used it for millennia. That means trying to figure out how to protect village sites, cemeteries, and places of profound religious importance, which adds a whole new layer of complexity to this programming challenge.
So when you're faced with this kind of overwhelming complexity, you've got competing land uses, ecological fragility, sacred history, you have to start to wonder, is a top-down command and control plan even the right tool for the job? This kind of challenge, managing a system with countless unpredictable variables, well, it's not just an environmental problem. It's a problem that also shows up in a totally different field, the development of artificial intelligence. So what if we looked at Hanford through that lens for a second.
Now, this quote is actually about designing a new kind of AI, but just listen to how well it applies here. It's suggesting that with really complex systems, you can't just issue commands and expect them to work. You have to develop a shared intuition, a way of observing, understanding, and kind of co-regulating the system. What if Hanford isn't a problem to be commanded, but a system to be understood?
Using this framework, we can kind of see the story of Hanford in 3 stages. It began as pure chaos, the raw, messy, toxic result of the Cold War mission. Then, this massive land use plan represents form, humanity's attempt to apply rules and structure to all that chaos. But maybe the ultimate goal isn't just a better set of rules. Maybe it's reaching law, a deeper, more intuitive understanding of our role as stewards, a universal principle of care that guides everything we do.
And this represents a huge shift in perspective. Hanford isn't just some giant engineering problem you can solve with a bigger budget or a smarter plan. It's a complex, living system. It's part toxic, part wild, part sacred, and it seems to demand a different kind of intelligence from us, one based on listening and adapting, not just commanding and controlling.
And this, right here, this brings us to a much, much bigger question. One that goes way beyond the borders of this one contaminated site in Washington.
The lessons from Hanford really apply to so many of our biggest challenges. It doesn't matter if we're talking about nuclear waste or global climate systems or even the rise of artificial intelligence. We are constantly creating things that are just too complex for simple command and control.
And that leaves us with this final, really provocative thought. When we face these immense systems that we ourselves have made, what is our role supposed to be? Are we just programmers trying to write the perfect lines of code to control the outcome? Or does our responsibility call on us to be something more? To be stewards, maybe gardeners, or co-regulators, developing a shared, intuitive understanding with the powerful, complex, and living world we are helping to create?